Hi, this is Dunk Sargent. Welcome to the Karst Valley Railroad. All aboard! Today we're going to revisit the ability of locomotives to negotiate the 183mm KATO N-scale Unitrack curves. Previously, we used only the Bachmann EMD SD9, item number 62353. This is a 6-axle locomotive. It apparently handled the tight curves well, although there was a noticeable grinding. We will be retesting that. I have had several requests for the testing of a larger 6-axle locomotive, so we will be testing the Broadway Limited GE ES44 AC, part number 7298, which is longer than the SD9. This length is really what makes the difference. I will also be testing a Bachmann S4, item number 63151, which is an EMD SW1 switcher locomotive. This is a 4-axle locomotive and is right-sized for the 183mm curves. The testing with this locomotive is to show a contrast with the larger locos and also test the modified number 4 turnout. We start out with the ES44 AC on a simple loop. I have boosted the volume on this clip so that you could hear the click as the loco goes into the curve. This is caused by the rail end burr, that is a slight ridge left from cutting or stamping the rail to length. This is also known as shear burr, which may be more accurate since KATO Unitrack rails are cut by a stamping process. Obviously, these defects can have amplified effects in these tight conditions. I later used a simple fingernail file to lightly remove the burr until my finger would no longer catch on the joint. Don't take too much material off though. And yet the transition from straight running to the curve still causes a bit too much stress, in the form of the wheels catching on the inside of the joint, on the vertical surfaces which also have a burr. Also, there is always binding when in a curve, but the tight radius just makes it so much worse. The wheels actually catch on the exit of the curve as well. This locomotive actually derailed coming into the curve on the right of the screen the first time I ran it. Too bad I wasn't recording it. It bounced right off. Notice that the length of the loco also causes a large end throw. This will cause problems later when pulling rolling stock around. I have now added a number 4 turnout with no straight track running into it. I am modifying my number 4s, which I still want to use for length considerations, and having a straight piece off the curve defeats that purpose. As I have said before, one might just bloody well use a number 6. Scotch take it. We'll see how that works out in a future video. I've put a link to a video in the description on modifying the number 4s. Now watch the derailing that occurs when the first coal car exits the curve. The first coal car may have already been derailed as it entered the curve. Running backwards into the number 4 turnout results in a serious derailment. As discussed in previous video comments, this is primarily because of the end throw of the locomotive pulling the coal car off the tracks. Adding a straight track before the turnout might relieve this slightly, but I am deliberately not doing that. Pulling the cars out of the siding started off well, but as soon as the locomotive end throw swung out the first car, it was pulled off the track. You can see its little shake just before it goes out of shot on the left of the screen. This also happens when entering the curve from the straight track. Clearly the car is jumping off the track well before it hits the curve. Now we are going to run some tests with the Bachmann EMD SD9 6-axle loco. This locomotive has been sitting in its box for a few years and immediately questioned me with, "Who disturbs my slumber?" I put it through its paces for a bit before testing. Yes, the track was clean. Notice the grinding of the wheels as the locomotive rounds the curve. That should be enough to let you know that running 6-axle locomotives on 183mm curves is a non-optimal situation. Now watch the end throw of the SD9. It is shorter, but is still in the danger range. On modifying these number 4 turnouts, it is recommended that the outer rail is notched slightly on the inside. Rail end burrs, both top and inner faces, are slightly beveled, and the outer point is also beveled on the top and the inner face to minimize bumping and make a sharper point. These modifications appear to have reduced, if not eliminated, the need for a piece of straight track coming into the turnout. Lastly, we are running the 4-axle Bachmann S4, formerly named the EMD SW1 switcher locomotive. That is what goes well with the 183mm curves, and you would expect a switcher to be able to handle the 150mm curves as well. Pulling out and back into the turnout works very well. It has always been the common conclusion that 183mm curves are just too tight for 6-axle locomotives. You might be able to get away with running them for a time, but they are never going to be reliable, especially when pulling rolling stock. That said, I still wanted to do this video so as to explain why running them on tight curves is inadvisable. 6-axle locomotives exceed the practical curvature limits of 183mm radius track.
That's about it. I'm Doug Sargent with the Karst Valley Railroad. Thank you for watching. Don't forget to like and subscribe. Over and out.